Ever pondered how a mere flick of a switch can illuminate an entire room, or how a simple press of a button can set a machine in motion? These everyday phenomena are powered by something we often take for granted: electricity. In the heart of the matter, electricity is all about the movement of electrons. These tiny particles orbit the nucleus of an atom, and when they move from one atom to another, they create an electric current. Imagine a bustling city where electrons are the citizens and the wires are the roads. The citizens move around the city, going from one place to another, and it's this movement that we harness as electricity. Now, how does this movement start? That's where electric fields come into play. When a battery or a generator applies a force, it creates an electric field. This field pushes the electrons, causing them to move and create an electric current. Think of it as a gust of wind, pushing leaves along its path. But just like you can't see the wind, you can't see an electric field. However, you can certainly see its effects. When you plug in your phone and it starts charging, when you turn on your TV and your favorite show pops up, when you turn the knob on your stove and it starts heating up, these are all effects of the invisible electric field at work. And just as there are highways and side roads in a city, we have high voltage and low voltage in electricity. High voltage is like the highway. It can move a lot of electrons quickly, while low voltage is like a side road, fewer electrons moving at a slower pace. And the rate at which these electrons move is what we call current. Now you might be wondering, how do we control this movement of electrons? Well, that's where resistance comes in. Resistance slows down the flow of electrons. It's like traffic controls in our city analogy. Some materials have high resistance, like rubber, and they slow down or even stop the flow of electrons. That's why they're used as insulators. Other materials like metals have low resistance and they let electrons flow easily. That's why they're used as conductors. To summarize, electricity is a form of energy resulting from the existence of charged particles, such as electrons or protons, either statically as an accumulation of charge or dynamically as a current. The movement of these electrons from one atom to another forms an electric current. This movement is caused by an electric field, which is created when a force is applied by a battery or a generator. The amount of electricity, or the rate at which these electrons move, is called current. And this movement can be controlled by resistance, which is determined by the material the electrons are moving through. High-resistance materials like rubber slow down the flow of electrons, while low-resistance materials like metals allow for easy flow. So, the next time you flip a switch or press a button, remember the bustling city of electrons, the invisible force fields, and the traffic controls that are working together to make that magic happen. And that, in essence, is the fascinating world of electricity.